You might already know how to scale a system using vertical or horizontal scaling. You might also be using the scale cube concept by following the three dimension of scalability. But that might not be enough if you don't enable the fourth dimension of scalability. Hi, I'm Rajesh, and in this video I'm going to explain the fourth dimension of scalability, which will help you achieve the true scalability for your system. Let's start. You might already know the vertical and horizontal scaling concept. So in vertical, we add more resources to a server to scale our system, and in horizontal we add more servers to scale our system to handle more load, right? So here this is the basic concept for vertical or horizontal scaling. The second one, which is more used in complex systems, are microservices. That is the scale cube concept, where we have x-axis where scale by cloning, y-axis where scale by splitting different things, right? And then z-axis where we say the scale by data partitioning, right? So these are the three dimension of scalability explained by the scale cube concept. Okay, this is scale cube, right? So x-axis scalability, scale by cloning, means where we split by similar things, right? For example, horizontal scaling, right? And scale by splitting different things means scale by function or functionality or by subdomain, like we do in microservice, right? So like microservices. And data partitioning we already know, like data shard that we use. By using that, we can create multiple shards to hold the data, right? So that is how we scale our data using the z-axis scale by data partitioning. So these are the three dimension of scalability where we can scale our system by doing all this, right? Now let's take an example. So think like we have this client, right? And then we have this server, right? Now think like this server takes 200 milliseconds to process a request, okay? And here this server can process only 5 requests at a time, right? So from client to server, if 5 requests are sent at a time, then this server can process. But think like here we have response time SLO set up for this server is 1 second. Means this server has to process one request in max 1 second and return the response, right? But here if you see, this server takes only 200 milliseconds, right? So within 1 second, how many requests this server can process? 200 into 5, right, into 5, right? 200 into 5, 1 second. So 1 second it can process 5 requests, and 5 requests it can process concurrently. So total it can process 25 requests in 1 second, right? But here if you see, if we are sending 5 requests to this server, this can process 5 requests at a time, right? But if we send 10 or 20 requests, right, at a time, this server will accept only 5 requests and rest will be rejected. Why? Because this server can process only 5 requests at a time. Now if we want to process 20 or 25 requests at a time, right, or when we are sending 20 or 25 requests, we have to add more servers, right, so that we can process more requests at the same time, right? And here we are following this scale by cloning or horizontal scaling. But here is the catch. What we can do in place of adding a new server, right? If we have something in between which can hold the request and release based on server capacity, like from here 25 requests and here at a time we are releasing only 5 requests to server, right? Then what will happen? In 200 milliseconds this server will process 5 requests and return, and then 5 requests will also be processed and return, like that. Within 1 second we can process 25 requests, right? And we don't have to reject request more than 5, because here we have a temporary area where we are holding these requests, right? So now in place of adding more servers or following scale by cloning, we are able to increase the scalability of our system by having a better communication between client and server, right? So here we have improved the communication, and as a result we improved the scalability of our system, right? So this is one example, okay, and this piece we can think like any type of queue or something which will basically take these requests and release as per the server capacity, right? So this is one way by which we can see, like we can increase or enhance the scalability of our system without using any of these techniques, right? Now think like a bigger scenario. Okay, so here if you see, like suppose we have a system like microservices implementation which we have used all these aspects, right? So how we will have this? We can have like this you can say like user service, order service, this is payment service, right? So if we have these three services and we might have an API gateway in front of them, and here we have two database shards, db1, db2, right? And these we have created, right? Now this may not be the perfect implementation, like we are not following the database per service pattern here, but just for this particular example, suppose we have these databases, right? And here this API gateway is basically connecting to these services, right? And here we have our user, and this is a kind of mobile application, right, from where we are getting the request, right? Now the thing is, here we have multiple instances of these services and here single instance, right? But things like this, in place of thinking the different or multiple instances, let's reduce the complexity and first go with single instance for now. So when the request will come from client to server, an order service suppose takes 1 second, right, to process a request, and payment service also takes 1 second, right? And a request will come from the client, right? And here we also have things like inventory service, right? And this also takes 1 second, right? So when request will come, it will go to order service. Order service will check for the inventory. So order service will call inventory service, and then based on that return the response and payment will be completed, right? Now the thing is, this request which is going from here to here to here and then return, right? Here how much time it will take? It will take around 2 seconds, right? Because request will come here and then it will return the response, correct? But without using any of these concepts, if we just enhance this communication, right, and we have kind of async communication between these, right, or decoupled communication using events, after putting the request for inventory check, this service can take the next request, right? So within 2 seconds it will be able to handle 2 requests in place of previously it is handling only 1 request, because communication is synchronous from order to inventory, and once it response return, then this flow is completed, and till then this order service will be on hold, right? So 2-second 2-second response time is now is still 2 seconds, because 1 second this service will take, 1 second this service will take, but the scalability is more, right? Because after putting this message in this queue, this order service can take the next request, and within 2 seconds it can process 2 requests, right? Overall response time will be 2 seconds only, but the scalability is improved only by using this enhanced communication pattern, right? So we are not using anything from this, but we have a better scalability. And same for database calls, like how we are using the connection pooling, right? Which protocol we are using, right? And how we are basically caching the communication, right? Information. All those things will add to the scalability here, right? And here, like service to service, right? Communication. Whether we are doing using the REST or gRPC, right? Based on that, this scalability will be impacted, right? So we have better scalability if we use gRPC, right? Another aspect is if we are using service mesh, right? Like sidecar pattern, right? And there also we will not be using any of these options, right? But we can increase the scalability by using the service mesh, right, of our entire microservices implementation, right? So these are some of the ways by which we can increase the scalability of our system without following these concepts. And here I am not saying these concepts are not important. We have to use this, right? We have to scale by cloning, by adding more servers, right? Or creating microservices to scale our domain, or by decomposing into subdomains, right? And data partitioning will improve the scalability of this, right? But if we don't use the communication scalability, which I refer as scaling by enhancing communication, right? So it is scaling by enhancing communication, right? So if we don't use this, then we will not be efficiently using the resources, right, to achieve the true scalability, right? So if we want to achieve true scalability by efficient utilization of resources, right, then we have to use the fourth dimension of scalability to basically scale by enhancing communication, right? And this way you can see, like we can say, like another dimension is there which we can imagine in this queue for this fourth dimension, right? And that way we will be able to scale, right? Now let's see specifically what are the common ways, or top 3 or 4 ways to implement this scaling technique, right? So how we can do? Number 1 is improve protocol. So we can improve the protocol, like here I said in place of REST we can go with gRPC, right? or in place of HTTP we can go with TCP IP, right? So we can improve the protocol, right, based on the scenario, right, to have better communication for scalability. Second, we can have like service mesh like this, right, to have the better scalability where you have complex environment, right, multiple services communicating with each other, right, and that communication may be very complex, right. When the number of services will increase, this communication will be more complex. So in place of having like this, we can use the service mesh, right, by using the sidecar pattern to simplify the communication, right, and enhance the scalability of the system, right. What is the third one? So we can follow event driven messaging where we can basically communicate between services using a kind of pub sub pattern, right, or using an event grid or something by which we can publish and subscribe to the event, and that way we will be able to scale our system, right. So here compare these approaches like this one with the synchronous or the direct communication, right, where those two servers are engaged in a synchronous communication, right. So both are blocked until the complete work is not done, right. Whereas in these scenarios, first service will put a kind of request and another service can take up based on its capacity, complete and respond, and meantime the first service will be free, right, or available to take more requests or more work. So that way we have increased the scalability. Now the fourth one is you can think of API gateways, right. So API gateways is another way. If you see here, so we have this API gateway, okay. So think like we have a container pod or something where we have set up this API gateway, right, and here we have user, then we have our mobile app, then here we have a load balancer like ELB in AWS or front door in Azure, right, like that, and that is basically redirecting the request to these API gateways, and API gateways is handling these communication with the microservices or internal services, right. Now here suppose this API gateways capacity 3k request at a time, right. Now if we are sending these requests from client and directly to here, right. So then we have to send 3 requests to API gateway, one for user, one for order, one for payment, or maybe the different services in a flow, right. From here we will be sending 3 requests, right. But if we enhance the communication here, right. So if we enhance the communication here, for example, we implement the aggregation pattern, right? We implement aggregation, right, on API gateway. Then what might happen? From client we can send only one request, and then API gateway will call multiple internal services, get the response back, aggregate and return to the client. So that way we have reduced the number of requests from client to API gateway, and that way we can save some of the resources. And so as API gateway is able to handle only 3k requests, but earlier, because every client is sending 3 requests, so only 1000 client or 1000 users will be able to send request at a time to API gateway. Now 3000 users or clients will be able to send request to API gateway, right? Because of the number of requests reduced from 3 to 1 between client to the API gateway, right? So that is one way of aggregating the response and reducing the number of requests, right? So here we have again not used any of these techniques, but we have enhanced the scalability, right? So this is another way. Similarly, throttling and other patterns we can use to enhance the scalability by enhancing the communication, right? So these are the 4 basic ways, but there are many ways by which we can enhance the communication and have a better scalability, right? Now why we want to use this as a 4th dimension, right? Because if we don't consider this as a 4th dimension, right, then this cube is incomplete, right? This cube is focusing only on these 3 aspects to scale a system, whereas the important aspect of enhancing communication is missing, right? So this cube concept is not complete until and unless we add this 4th dimension, and that dimension is basically to scale by enhancing communication, right? So what we have seen here, based on that, what I can say is without 4th dimension, the true scalability is not possible for a system, right? And this 4th dimension we can use as primary tactic or pattern to scale a system, right? Many times before thinking about any other dimension, right? Before adding a new server, we can see how we can improve the communication to scale this system, right? And that way we don't have to add more resources, right? And because we are not adding more resources, we will be simplifying the architecture and optimizing the cost, right? So this is a kind of important dimension which we should be using, right? Now that's all for today, and thank you for watching, and let me know what do you think about this 4th dimension in comments, right? Also let me know if you know or if you think there are any other dimension which we can add to enhance scalability as we scale our systems, right? Thank you. Happy learning. Bye.